campus. And it's my pleasure in introducing the speaker of this afternoon, Dr. Jayachandra Bingi. I'll just share his profile for your convenience. And yeah. Yeah. I hope that audience are able to view the profile of the speaker. Okay. The topic Dr. Jayachandra Bingi is going to talk on is bio-inspired mechanisms, particularly focusing on optics and photonic technology perspective. Dr. Jayachandra Bingi holds a PhD from IIT Madras in physics. He specializes in physics, optics, and nanophotonics, as well as bio-inspired design and engineering. He was also a postdoctoral research fellow at the School of Mechanical and Aerospace Engineering, Nanyang Technological University, NTU, Singapore. His professional service achievements include research reviewing of journals like Plasmonics, which is a Springer, journal, optical materials from Elsevier, scientific reports of Nature Publishing Group, and IEEE Photonic Journal of IEEE Group. He also has several journal and conference publications on a wide range of topics revolving around physics, along with co-authoring a book on modified photonic processes in dielectric plasma random media. So the list goes on. For want of time, I am making it very brief. And it's my pleasure. I am being a physician worked in quantum chaos to introduce a person like Dr. Jayachandra Bingi to the audience. Over to Dr. Jayachandra Bingi.
Thank you, sir. I'm just sharing my screen.
Sure.
Ganeshan sir, you have to take off. Stop sharing.
Sure. Wait just a minute. And just it's gone. Let me see. Yeah.
Okay.
Is it all right now? Yeah. Sorry.
Yes.
Is it visible?
Yes.
Yeah, of course.
Just go to presentation mode.
Yeah. Yeah. Good afternoon, everyone. Actually, it's a tea time, so hope I'm not disturbing people. So, I'm from Indian Institute of Information Technology, Design and Manufacturing, which is the engineering institution, which is the institute of national importance. Focuses on engineering with a focus on product development. So our works mainly, even though we do the basic research, our target will be on product or technology development. In that, we established a laboratory, a dedicated laboratory for bio-inspired research and development. In a short form, we call it as BIRD. So that is our laboratory. And you can see the campus there. So today's topic title is Bio-Inspired Mechanisms, Optics and Photonic Technology Perspective. And here, I don't think I can cover completely, but with a single case study, what we are doing now, I will try to explain how we can explore the bio-inspiration in the case of optics and photonics. So before starting that photon bio response, if you see, we have two broad subjects called optics and photonics. Generally, we use them interchangeably. That is, somewhere we'll use photonic, somewhere we'll use optics. But in my opinion, whatever the light propagation and modification while it is propagating, I consider as optics, and generation annihilation, that means absorption and emissions processes, I'll take under photonics. So what we actually see in the nature, that is the question. So that question can be answered with this, that how a bio entity or a species responding to the light, or how a bio entity in the species responding to the light, and how species is responding to the light or electromagnetic radiation. So that is what we need to see in the nature. Definitely we'll get some example like photosynthesis, or if I ask you all, are you able to see the slide? You all say that yes, because there is some process that light is passing through your eyes. There is a I don't say simple, there is an optics. So with that background, I would like to show that vision. The basis of photonics or optics in the case of bio-inspiration, where we can take bio-inspiration, is in the case of vision. You can see that species is called snake. I think everybody's favorite to see from far away from. Okay, you just look at the eye. If you see the eye is not like us. Our pupil is circle in shape, but you just look at the snake's eye. The snake's eye is not a circle, it's actually a slit. Then comes the question, is there any speciality for this vertical pupil or horizontal pupil, horizontal slit pupil? Yes, there is. The study shows that the animals or any species with the slit pupil can see in the night. That is, they have night vision capability. That is our basis. We thought that maybe there is something special in the case of that eye optics. So if you see there in the eye, you'll certainly find one lens and you will find one vertical slit. And also that lens works as a circular aperture. So this is our the experimental setup. You can see here, I think, yeah, here we have a slit. Here we have one aperture, circular aperture, the diverging light, and here lens, and here one vertical slit. What actually we observed is really interesting, because in the night time we don't see too much brightness, very meek light is available, that too very well scattered or diverged light. In those particular conditions, if the light travels through this particular optics, that is first circular aperture, lens, and the vertical slit, what happens? Generally, we can say that if the light passes through the circular aperture or the vertical slit, then diffraction happens. There may be multiple diffractions. But here one interesting thing we observed is the diffraction or the compound diffraction pattern is actually creating the patterns which are resembling the Hermite-Gaussian beams. You can see here. This is due to diverged light through these optics, and this is due to non-diverged light through the same optics. That means we cannot compare the circular pupil eye with the vertical slit pupil eye. There is a difference in optics. So what is that difference? Because what is the difference? If you see, there is a synergic diffraction. We all know about Fresnel diffraction. We all know about Fraunhofer diffraction separately. But if the Fresnel and Fraunhofer diffractions occur together, what happens? That is what the recent paper we published, which is inspired by this particular eye optics, which are having the slit pupil. Okay, so this way, in this we found a result that this particular intensity distribution is Hermite-Gaussian beam distribution. You may ask me, what is the use of that Hermite-Gaussian beam? The Hermite-Gaussian beam can be converted to the Legere-Gaussian beam, which are the orbital angular momentum beams, which are most important in optical tweezing. So this way, that pattern is very interesting. That means these species are not seeing the same way we perceive the environment. So that is the way we actually explored that eye and created one particular optics and achieved this pattern, which is nothing but the synergic. Fundamentally, this is synergic effect of Fresnel and Fraunhofer diffraction. That way we can use the bio-inspiration. This is only inspiration. just an observation how that particular eye with a vertical pupil is working. That's the first example. I can say you can read the paper we recently published in 2020, that is a demonstration of synergic Fresnel and Fraunhofer diffraction for applications of micrograding application. It's a classic example. And the second thing is snake's radar. That is, if you ask me, if the snake is hunting, whether snake is watching with the eye or it has any extra capabilities to sense the objects or prey. So this way, if you see, along with the special optics eye, it has one more organ called pit organs. These pit organs actually can detect infrared radiation. That means synergically, it is using visible UV with the normal eye and infrared detection by the pit organ. You try to understand, it is actually synergizing the detection of 3 regions into single region. So that is what actually snake is doing. From this, what we actually did, if you see, snake with the normal eye, see the rat like this. This is only representation. So like this, it can see where it can see because of the protein it has in its eyes, that is called Pison, I think. With that protein, it can detect the yellow to UV region, and with the pit organs, it can see the object like this. That means it is able to synergetically see in what is happening in the brain is the very important thing. It is actually synergizing these two and overlapping these two, and it is able to see, or it is able to pursue in an enhanced capability, with the enhanced capability to hunt the prey. So this we have taken as a basis for our further research, and we have taken it as for monitoring the water. And you just see here, we have taken a pure water, which is called a datum H2O, and we just added some toxins, and we have taken the photos. We just taken the images of that, and the ambient light is, we kept white light, darkness, UV light, and UV. Like that, we changed the environments in a different way, and we have taken different photographs like infrared region and UV region. So you can see the different images, but with the naked eye, you may not see the difference. But by using the cosine principle or cosine similarity principle, we actually compared these things with the other one. When we compared that, you can see here, we calculated the difference between the two images. In the left side, you can see, with the naked eye, you can't see anything. This is overlapped image, that is UV plus infrared, where in the water we added NaOH. So some toxin we added. This is the pure water. This is also UV plus infrared images overlap. And here also we added C2H2OH, C2HYOH, where we have superimposed two images. Now you can see in the right side tables, here the grayscale only IR image can show the difference 3.6% only. But if it is a color image, it can show 58%. Just to see the difference, if it is UV plus IR, then it can show 80% difference between the normal water and water with NaOH. And here 73% difference from the normal water to C2H5OH toxin added water. So this way, it is very clear. Initially, we understood that it's a primary evidence that suppose if you one eye is looking at infrared radiation, another eye can look at UV and visible radiation. Your brain actually synergetically process it and try to understand it. And that vision is completely different to that of what we are actually perceiving. So the perceiving, that perceptual engineering, we can definitely do in the case of vision. So with this, we can actually show the difference between UV and IR, which is clearly showing the difference between toxic water and normal water. So this concept can be applied to determine the toxic water. So this is the, at the first round of experiments are over. Now we are going for making one product called water scope, in which we are going to use the infrared camera and a normal camera with UV filter, which is run by the Raspberry Pi control system. And the back side of that, we have screen. So with which we are going to monitor the toxic water, and using this synchronization or the uh, overlapping the UV light and infrared regions together. Somebody may ask, it's a multimodal imaging. Yes, of course, it's a multimodal imaging, but from snake, what we observed is it is actually processing it in a very different way while it is hunting. So that capabilities we can develop. Now we used only simple cosine similarity principle there in order to compare the two images. If we are able to apply the artificial intelligence algorithms to really compare the two images and come to the conclusions or interpretations, this is going to work in different cases, not only for water, that may be oil pollution or different applications we have. So that is what, in a simple manner, the optics and photonics from the bio-inspiration. So study of bio-inspiration, we take some inspiration, we create a work, and we develop a technology. With that case study, I just wanted to explain. So this work actually, we started with the motive that we have to give something to the Indian Army 1.5 years back. So I think first round of iteration is over. We are filing a patent now. So I think I can dedicate this to our Army Bravehearts. Thank you very much. And we are in a need of many interns and people who can come there to IIITDM and work with us. So if somebody interested, please contact us. Thank you very much.
Thank you, Dr. Jayachandra, for your wonderful presentation and exciting, inventions, and also your interest to, contribute to the country. Thank you. I would now request the moderator to decide the questions and answers sessions.
Thank you, Dr. Jayachandra, for a wonderful applied physics topic. There are a few questions from the audience. One is from Testa Ahuja. She asks, snakes visions of UV and IR simultaneous or not?
It's simultaneous. That's what. That is the specialty. It's like a synchronized.
So in that case, do we know which one is actually doing IR imaging and which one does UV?
Yes, because I have shown here this pit organs. Is my cursor visible?
Yes, we can see it.
Yeah. This pit organ is there. This is the normal eye. And this is the pit organ. The pit organ actually detecting infrared radiation.
Okay.
And the normal eye actually detecting U from yellow to UV.
Okay.
No red region. from yellow to UV region. There is a protein called pitsign, I think.
Okay.
Piscine or pitsign, that is actually that can detect only from yellow region to UV region. So those are the two different regions.
So there is one more question which is kind of interesting.
Yeah.
Is it just a detection or quantification also?
Yeah, quantification is possible.
Detecting or it can quantify also?
Yeah. Quantification is possible, but in a first round of first iteration, we are only interested in, can I distinguish the toxic and non-toxic? We have to do further.
Okay, so thank you very much for this wonderful talk. Over to you, Professor Ganeshan.
Maybe Dr. Jayachandra, before leaving, I have a question. You have used, multiple cameras, but then, when you use all this stereo vision, what happens is the distance matters, and also what is the resolution. When you are fusing the images, and then if you want to derive, intelligence out of it, how do you decide that one?
Actually, we keep the distance the same. If you see in this one,
okay.
Here we mounted two cameras.
Okay.
Here we mounted two cameras at same positions. Maybe
okay,
you can consider this as a origin. Maybe this point as origin.
Okay.
So one camera is at x1 and another camera is at minus x1.
Very
Just
good.
for understanding purpose I'm telling. So maybe the distance is the perpendicular distance between two planes.
Very good. Okay.
So two planes, that way we will take, and synchronization, all those things we will do in the Raspberry, like overlapping.
Okay, fine. Okay, thank you, Dr. Jayachandra, for your inspiration section.
Thank you.
Thank you. Thank you.
So we can go for the next.
Can we go to the next session?
Yes.
Okay. So thank you all participants. Now we are moving to the next speaker, and we have with us Dr. Aditya Kumar, and he is from IIT Dhanbad. He is going to talk on bio-inspired nanotribology and interfacial science. Dr. Aditya Kumar is currently an assistant professor at IIT ISM Dhanbad. He received his PhD in material science from University of Siegen, Germany. He also acquired his postdoc in the Department of Mechanical and Aerospace Engineering at the Ohio State University, Ohio. He has over 100 publications on his name and displays expertise in chemical engineering, specifically is the fields of nanotechnology, surface science, interfacial science, nanotribology, and coatings, etc. Now, over to Dr. Aditya Kumar.
Thank you, Dr. Ganeshan. Am
Thank
I audible?
Sir. Yes.
Yeah. Okay. Thank you, Dr. Ganeshan, for warm introduction. Thank you to all for coming here to listen me, and for other speaker too. Of course, it's a very hard time, COVID-19, and we have to go for virtual. But it's nice. We will at home and we can listen many good things. All right, even on Saturday and Sunday. So first of all, I just share my screen. Okay.
Yes, we can see. Would be nice if you can go to presentation mode.
Yeah. Okay. So as already Dr. Ganesan already introduced about me, I'm a faculty in Department of Chemical Engineering, IIT. And maybe you heard about lots of about ISM. ISM is actually one of the oldest institute of India. It's they started in 1926 actually. So it's about 94-year-old institute. And 2016 it's become IIT. So we have now IIT ISM Dhanbad. And so today I'll going to talk something about on bio-inspired materials and some aspect of the nanotribology. Okay, in that first, uh, there are lots of students here, so I believe some of the students may be interested to know about what are the bio-inspired materials. And in that bio-inspired materials, I'll discuss a little bit on the super-hydrophobicity. Of course, the topic is related to nanotribology, so I have to cover with the tribology. Of course, at the end, I will conclude my talk with some remarks. So here, what is bio-inspired or biomimicry? Something we learn from nature and we just copy. Mimicry means we copy bio from nature, right? So we come something copy from nature, we call it a bio-inspired or biomimicry. Inspired means we get the inspiration. We learn from the nature for the good thing. So as you know, nature is good as well as dangerous. So we have to learn as a model, but we have to take care of everything, right? So nature work as a model, nature works as a measure, also work as a mentor. So the things we get from the nature, we call it a nature inspired, right? For example, Taylor lily. If you see the left side, this Taylor lily, if, if you see this design, it's a beautiful design, and nature tells us, come on, you have a good design. Why don't you use for our the practical applications? So based on this Taylor lily, you can have water mixture. You can see this. Now, gecko feet. Most of the people are they are afraid with the geckos, right? But gecko is very beautiful in nature. They can climb easily. So in their feet, they have some nanostructures. So because of the nanostructure, their properties, they have already developed gecko tape. They also gave the name of the tape is gecko tape, right? Shark, another example of shark. See, shark is very big body, and it can easily swim into the ocean or sea, right? How? So big. So reason is it's having some nanostructure. So it's inspiration to us how it swim. And if we look into this, their structure, and we copy or we mimic their structure for the swimming suits or textiles for the swimmers, they can easily swim. And you cannot believe or not, swimmers in the world champions, they win or they lose the competition because of my fraction of the second, right? So these structures are very important. So they can have low drag and they can swim faster. Here, another example is termite house. This is a termite house, and in Zimbabwe, Harare in Zimbabwe, they made a e-sport building. This based on this termite house, and this building is so beautiful in nature. You know, Harare is always most of the time they have 40 degrees centigrade, and so they have to have lots of air conditioner to survive or to sustain in this building. But if they mimic this design, termite design, they don't need air conditioner. Their building is cool, right? Another example, bullet train. Japan, China, Europe are famous for the bullet trains or very high speed trains, right? So what they have, they made their the front part of the train with the kingfisher's nose, right? So how it happens, how they be inspired? If you see the kingfisher is always in air. His mouth is in air, but when it sees some insect or some fish is swimming into the water, it's fastly take that insect. How? because it's safe, there is no noise, nothing happens, and it can easily go one phase to another phase, from air to water. So they have thought, Japanese thought, why we don't have the same shape of our bullet trains? So they designed, and it works very well. Other examples are monkeys, right? Chimpanzees, how they heal themselves because they live in a tree. So most of the time they play one branch to another branch and they get injured. But due to this, their self-healing nature of these trees and their fur skin, they can easily heal. Here, another example of dolphin, right? So maybe you heard about the tsunamis. People don't know about tsunamis. They can't hear, but dolphin can warn people. Tsunamis, right? So we have to inspire from them. Same for lungs. If you see the lung structure, very beautiful in nature, and it can also help for the sequester carbon. Chinese developed nest waste. They inspired from the bird nest to create or to design their national stadium. Right, that you have seen in Olympics, right? Another is bionic car. They inspired the bionic car with the box fish. This is a box fish, so it's having low drag, very low drag, so it can swim very fast. So they inspired to create this bionic car. And everybody has seen the road studs, right? And they inspired this road stud with the eyes of the cat. You can also get the inspiration from butterfly. So beautiful, their color, their wings. So if you inspire, if you see their structures as you create in your house, outside the house or the window, you have reflective window, right? Another example is lotus fact, right? So if you put a drop into the lotus leaves, you always see the spherical shape of the spherical beads of the water droplet. And if you tilt the surface, it rolls off. While rolling up on the surface, takes all dirt away, like this. Mean it makes the spherical shape on the surface, and its surface is having lots of dirt. While rolling up, it takes all dirt away. So this nature make these leaves self-cleaning, right? So here I'll just introduce among all bio-inspired materials. I'll take the example of Lotus fact. Okay, so Lotus, before going to the Lotus fact, we should know about the hydrophilic and hydrophobic. Hydrophilic means who likes water, like metallic surface. So what you see in the metallic surface, if you put a water, what happens? The water spread. It favors for wetting, right? In hydrophobic surface like polymeric or lotus or rice leaves, rose pellet, what you see, they always resist to the water. So we all are engineers or educated people. We always see everything with the numbers. So you measure the hydrophilics or hydrophobicity in terms of the contact angle. And contact angle is defined with this. If you make the tangent, the surface, that is the side of the uh, droplet, liquid droplet or water droplet, then the angle it makes with the tangent is a contact angle. And why? And here I start to introduce you one word is a super-hydrophobicity. Super-hydrophobicity when this contact angle is more than 150. Hydrophobic when the contact angle is more than 90. Hydrophilic contact angle is less than 90. And if we talk about the oil, oil contact angle, then we call it a super high oleophobic when the oil will make the contact angle with the surface were more than 150. Right. In the nature, we have lots of example, right? The legs of the mosquitoes, shark skin, butterfly wings, and lotus leaves. Now, how we create this super hydrophobic surfaces or super oleophobic surfaces in practical applications? So, with a carefully observation, scientists have seen this surface is having beautiful nanostructures. So, if you create this nanostructure, and of course, you have to have some low surface energy material. Because of this low surface energy materials, combination of this roughness, the water goes upward direction. So how you create in the artificially, you have to have one point. One thing is rough surface, another is the low surface energy material on the surface. And how you create the low surface energy material? What does mean of low surface energy material? Means they have some alkyl chain, long carbon chain, right? Like polymer, xylenes, or fatty acids, right? So these are having, non-polar, non-polar component. So the polar component, like they have one functional group which will attach to the surface, and the non-polar will go upward direction. So hydrophobic tail, mixed hydrophobic tails. And this non-polar will repel to the polar component of the water, because water is a polar component. So non-polar, polar repulsion. So you have the super-hydrophobicity. Why we need the roughness? In the in between of this rough surface, you will have the air trap. So this air, what air will do beneath this air, the water drop, the air tries to uplift the water drop. So your contact will increase if you increase the surface roughness, right? So these super hydrophobic surfaces are having lots of application, like anti-adhesion, self-cleaning, anti-fogging, anti-biofouling, corrosion evasion, drag reduction, anti-icing. I'll give some example. Right. Here is a transparent superhydrophobic surface. As you can see, this side is an uncoated glass surface. Glass is a transparent nature. So we have taken the glass for the substrate to do the superhydrophobicity. So this side is the uncoated part. This side is a coated part. So we can create transparent superhydrophobic coating. Okay, so with the superhydrophobicity, water will make the spherical in shape, and transparent means we can see the soul, right? So same coating, if we do the windshield or glass of the car, or in your mobile phone, or your optical device, electronic device, what will happen? You can see easily with the transparency. We have like more than 95% transparency, or about 100% transparency. With the super hydrophobicity, it makes the surface clean all the time. You don't need to have clean wipe your mobile phone, your laptop screen, or your car screen, car windshield, right? So as I said, this is having the self-cleaning property. Here you can see this is a super hydrophobic surface. So it makes the spherical bead shape of the water drop. This is color water, and these are the dirt. So the color water always take the all the dirt, and while rolling, this water drop will off from the surface, and your surface will be clean. Anti-fogging. Here in this example, we have uncoated aluminum surface. This is super hydrophobic aluminum surface. And this uncoated, what we have done, we have put both sample into the freezer for longer time, like for over a night. And after that, we put into the humid atmosphere. So immediately on uncoated metallic surface or aluminum, you see lots of water droplet. means the fog onto the surface, right? But in super-hydrophobic coatings or super-hydrophobic aluminum surface, we can't see any fog. So super-hydrophobicity also show anti-fogging nature. Here, one example is anti-corrosion, right? So one graph, this is electrochemical analysis. So uh, maybe some of the student will not understand this. So this is, I'll just tell you, uh, once you put your metal into the saline water or sea water, what will happen? Because of the NaCl, right, your metal part will be corrode over the time. But if you do the coating, super hydrophobic coating onto this metallic, what will happen? It will always repel this your seawater, and it does not let your material or your aluminum or metal surface wet. Once it will not wet, so you can't have the corrosion, because in corrosion you need to have water contact, moisture in contact. So here we have measured scientifically, and we found super hydrophobic surfaces are having high corrosion resistance. In this experiment, uh, they have coated glass surface. So this part, in this part, you can see this is a glass side and this is coated part. And we put the ice on both part. What happened? Ice accumulated onto the uncoated part, not over the coated. So this surface, because of this super hydrophobicity nature, they also show anti-icing in nature. Self-cleaning already I described you. All water separation. If you tune the wettability in that way, you can have water or one liquid repellent, one will not. Take an example. Here, this is a metallic mesh. We tune the surface. So that way, the surface is a super hydrophobic, but super oleophilic, means it like oil to pass through it, but it does not like water passing. So water is repellent to this surface, oil is passing through that. So if you have oil and water in a mixture and you just pour out the surface, because of the gravity, you can easily separate the oil from the water. And oil water separation is very huge problem for the industries, particularly for oil industries, right? Here, we did the coating on cloth. So when you eat food, right, and if you go outside, the cotton sheet or even in your car sheet, they are made of cloth, right? Or partially they're made of cloth, right? Otherwise, most of the time they use polyester or something, right? So anyway, once you eat food, what will happen? Part of food or particles of food drop onto your cloth, and after certain time, you can't easily clean those surfaces, and you feel very aesthetic look, and you feel so bad. Here, what we have done, we created the super hydrophobicity on cotton cloth, right? And we put the color water on uncoated one or coated one. After drying, what we have seen, this definitely become dried, but after drying, it left so much stain. But in this super hydrophobic surface, after drying, it leaves stain marks. So because of the super hydrophobicity, we can say we can have stain resistance. All right. Another is antibacterial. Here we also demonstrate antibacterial nature of the super hydrophobic surfaces. This cotton fabric, and after we put into the bacteria and incubation, what we observed, the bacteria is all over the cloth surface, but in case of the super hydrophobic surfaces, it make the clear zone innovation zone. That significant. So it this after coating, the bacteria does not come to the surface, or they easily kill the surface. Right. After this part, I'll go to another part is tribology. What is tribology? Tribo comes from the tribo word come from the Greek, means rubbing. Tribo means rubbing. Ology means science. So we can say the study of the rubbing things. Means tribology means when two bodies are moving with each other while in contact. The popular equivalents are friction, lubrications, wear. Right. So friction, I think all of you know about friction, right? Where lubricants, to reduce the energy loss, right? The tribologist, this is like history. Tribology is not very new actually. 2400 BC, they found tribology even in Egypt. One of the old statue they found they were using some lubricants such that this cord can easily pull out, right? So, and the most famous is tribologist is Leonardo da Vinci, and he designed lots of things, right? And he did sled friction test geometry, wall bearing, for wall test geometry he did actually. So we can say he's a first travelologist, non-travelologist, right? And tribology is all over us, from simple to complex, small to larger. Like for individual component, gear, bearing, brakes, clutches. These the example you have seen, right?
Dr.
Assembly.
Aditya,
Yeah.
can you take a couple of minutes? If you
Yeah,
conclude,
sure.
then we can take few questions.
Yeah, sure.
Okay, thank you.
So as I was saying, tribology all over the world, all over everywhere, from small to big. So here some example of you can see the tribology in shoes assemble part, right? Here manufacturing like rolling, stamping. So it's a where you can see the tribology. Construction like excavator, slurry and all. In natural phenomena like erosion, water erosion, you see the tribology. The tribology is very complicated, right? Only two things are in common. Two things common in all example I have shown you. Surface in contact, another is relative motion, right? The relative motion can be sliding, rolling, impacting. So based on the scale, we define the tribology in two parts, macro tribology or nano tribology. Nano tribology means once you talk about the very light load, or when the surface is the few atomic layers, the nano level, right? Then we call it as a nano tribology. For nano tribology, when we talk about the nano things, right, then we have to have very small, techniques to measure the friction wear at the nanoscale, right? So there is a one famous technology, scanning probe techniques, right? In that they have very small tip, very sharp tip, which move onto the surface, right? And it interacts with the atoms of the present on the surface, and it shows it gives the friction wear properties, right? Okay, there are big family. SPM family is like scanning tunneling microscope or AFM. So one is the most famous microscopy which we use for the nanotribology is atomic force microscope. So atomic force microscope, you have very nanoscale tip, right? Nano size tip, which is on to the cantilever, and it will give it. You can have nanoneutral load to microneutral load using this technology, right? And it will generate beautifully friction force, adhesion force, right? So this friction force you already know. So here I was talking about the friction. Actually, macro scale friction is different than the nanoscale friction, right? In the macro scale, we always assume friction coefficient is constant. If you change load or not, but in nanoscale, everything's changed. Friction coefficient can be more than one, right? Because in the nanoscale, you can also encompass with the stick slip phenomena. So your friction coefficient or friction force can be higher than your applied load, right? So friction coefficient is more than that, right? And with this nanoscale study, you can also distinguish elastic deformation and plastic deformation beneath the or interact the contact of the two bodies, right? And with this scanning probe microscope or nanoscale tribology, you can also do the rolling friction, right? And you can also measure the adhesion force, like particle. Why the adhesion force is very important. If you take the example of cement, so what do you want in the cement? You want the high adhesion force. But if you talk about the milk powder, right, what do you want in the milk powder? You want the milk powder will not stick to each other, so adhesion force will be low, you want, right? So this kind of study is very important. Where is also important, if you repeatedly do the same scratch, well, then we call is of wear, right? So with the nanoscale, you also, with the using of these scanning probe techniques, you can also study the in detail of the wear. So here I'll summarize quickly, right? Because we are out of the time. So with the if we take the example of the natures and we inspired from the nature, we can have lots of things. Of course, we have to innovate our ideas properly. Otherwise, this will be a dangerous, and we can make our life comfortable. Tribology has a vital role in industry as well as household activities. And with the help of scanning probe microscope, tribological aspect can be understand for these bio-inspired materials. Right. Thank you.
Thank you, Dr. Aditya, for your very informative session. Now I will leave it to Dr. Ramesh to take a few questions.
Thank you very much. And I have a few questions from the audience here.
Sure.
So I'll just read one of this. Is this anti-adhesive property is being used in recently developed PPE kits and masks against corona? This is from Nimisha Kumari.
Uh, what does mean actually? It does mean what is that virus adhesion onto the surface or
Yes, it
dirt?
looks like that. I mean, she might be wanting to know
Yeah,
whether
actually,
this anti-adhesive property is valid up to small scale, like nanoscale.
yeah, right. She is very right. We recently developed antiviral coating in our lab. Okay, and you might be here if you see our website IITISM, and you see the flash the news, and we created actually using the super-hydrophobicity
Okay.
antiviral properties on this.
Yeah. So there is one more question from Professor Suresh from VIT. What are the components of the super liquephobic cotton fabric?
Excuse me.
What are the components of the super liquephobic cotton fabric?
Yeah, actually, liquephobic means the which will repel lots of liquids, not only the water. Hydrophobic means for water, right? Oleophobic means we concern on the oil, right? Liquephobic it may covers many liquids
Yes.
from
So
low
his
surface
question is,
tension.
what are the components of that
Yeah,
fabric?
you can have low surface energy materials, particularly what example I have shown you. In that we use HDTMS, that's hexadecyl tetramethylxylane actually. and we simply immerse the coating into that. Okay, of course there is plus specialized xylene. Maybe the audience, who's the name who was asking?
Professor Suresh from VIT.
Okay,
He's a
so
faculty here in
yeah,
VIT.
okay, Professor Suresh, if you are listening, then you can contact me later, all right? And we already published one paper, this paper, whatever I've shown you in JCIS, you can refer that. All right. Okay,
So there is one more question, the
sure.
final question maybe. What is the lifetime of super-hydrophobic material? In
It's very tricky.
oil-water separation, how many times this material can be used?
This is very tricky question actually. See, for super hydrophobicity, you create the roughness as well as you functionalize the surface, right? And while rubbing or mishandling, definitely you degrade your low surface energy material, or your roughness, your nanostructure will damage, right? So you have to be customize your surface based on your need. So it can be damaged within a one cycle of you even rubbing with the thumb, or it can survive for years and years. So you have to decide, right? You have to optimize the things, right? Yeah. Thank you.
Okay, so
Any more
just
questions?
last one question.
Sure.
Did you check the biocompatibility of these materials based on ISO 10993 industry standards?
Yeah, ISO. If you use for biometry, bio things, right? If you for the body.
Yeah. It's so
So
the question says biocompatibility of these materials.
see, we were thinking to have the coating on stent, right? The sorry, bioimplants, which is basically used for the knee and your hip joints, right? And for biocompatible materials are available in the market like PMMA, right? If you use PMMA, PDMS coating, they are very much proven biocompatible materials. Based on that, we can have the super hydrophobic coatings.
Okay, so there are many questions, but since we are running short of time, I will post these questions to you via
Yeah,
email.
sure. Yeah, sure. They
Over
can
to,
contact. They
yeah,
can contact
oh,
me later. Yeah, thank you.
either they will or I will write to you.
Sure. Thank you. Thank you.
So, Professor Ganeshan, over to you.
Yeah. Thank you, Dr. Aditya Kumar,
Thank
for
you.
your wonderful presentation and useful, presentation. And on
Thank
behalf
you.
of the organizer, I would like to thank both the speakers of this third session. And also I would like to thank Dr. Ramesh, who was a moderator. As was rightly pointed out, because of want of time, we were not able to ask many questions. Otherwise, next time we would like to have more time from you, sir.
Yeah, okay.
Thank you.
Thank you. Thank you.
Yes.
Thank you.
Thank
Thank
you.
you. Thank you.
Thank you.
Thank you.
Thank you.
So,
Thank you, one and all.
dear audience, we will leave this session now and we will rejoin in 10 minutes. So you can use the same link and rejoin for the next session. Thank you very much.